Hello, 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 welcome back, welcome back, welcome back, and I am maxing out my mic. Whoops. My bad. There we go. That's still a little bit loud. I think that's good. Okay, welcome back, welcome back, welcome back. How's everyone doing? I missed some things during this stream and the last. During the starting period, we got a new follower, and during the last coding stream, we got a new follower. So I just want to start this stream out by saying thank you to both Jessica VTuber 110 and Mastakilla, I think is how you pronounce that. For the follows, I missed both of them. I don't know why I didn't hear the one in the last stream. I think I might have closed OBS or something because I didn't hear the stream elements thing go off. And it's loud enough for me to hear it when it goes off. But I don't know what happened there. But I just want to start this stream out by saying thank you to both of them for the follows. I never figured out what was going on with Twitch and OBS last time. I still have a few follower notifications missing, so I can't properly thank everyone, sadly. But yeah, I hopefully got that fixed, and I just kind of went through all my settings, and I couldn't figure out what it was. So hopefully it's good now. Also, I got a new help. Hold on, I'll switch over so y'all can see what we're going to be doing. I don't really need to stay on this screen forever. Actually, is there anything I need to talk about? Let me think. Do I have any updates? Anything? Oh, I changed the way my setup is. So now I have Twitch chat on screen. I don't have to rely on the phone. Because that was not the easiest thing to do last time. And it can also reach the size that is needed. And everything will move with it. So I have an actual setup going on now, which is good. And hopefully it would allow... Oh, excuse me. Oh, I got the hiccups. Hopefully it'll allow some... Hopefully it'll allow it to be easier for me. So let's go ahead and switch over to the stream. Hopefully I did this right. I did! Let's go, let's go, let's go. We did it right. Okay, so I don't believe I need OBS anymore, do I? Is there anything I need to change? Nope, everything's good. Yeah, so we could go back over here. Yeah. So everything's good. We're gonna be going through... Let me get the video that we're gonna be following up. Because I found a Pytorch tutorial.
So this...
Quiet! We're not ready for you yet. I found a Pytorch tutorial. We're not finishing it in this stream. We aren't going to get anywhere close to finishing it in this stream. I believe I put started in the stream title. Hopefully I did. Let me switch back over to here. Yeah, starting to learn Pytorch. We are starting to learn Pytorch. We are not finishing learning Pytorch in this stream. We have... This tutorial I found is 25 hours long. But we're learning Pytorch because during the last stream I was learning how to build a GPT. And it's doing great. I updated that code a little bit, as y'all can see. Hopefully. I need this open anyway because I use this phone for making sure everything's good. So let me just open this up. There we go. So yeah, as I can see, hopefully, yeah, everything. Where was it? Through this area got cleaned up a bit, and also changed. So now the vocabulary list is much bigger for everything. Oh, you know what I didn't do? You know what I forgot to do? This has 2. I believe this would have 2 of every uppercase word. We could actually debug that right now. Hold on. Yeah, so... Where's my index? Here. You know what? I also don't need all of this. This could say... This... is debug, so we could comment this out. Hold on. Let me just label it as debug. Remove this. Like that, and then we could go home, and then down, We don't need that. We do need that. That could stay. The print line could go. And then we could debug, get rid of this and this. Index cluster. And then this is also debug, so we can actually get rid of this just completely, because that was just for testing. So now if we run it, it should just be, yeah. It was a number of words was like 11,000. It should now be every word capitalized, or every word in all caps, every word in all lowercase letters, and every word in and every word in normal capitalization, like just the first letters capitalized. So I'm actually just gonna test. So yeah, here's index of it's 11,000. It was originally 11,468 because the index starts at 0. Words. So let me get a calculator out. Hold up. Hold up. Calculator. Let's put that over here. Ah, that's big. Where is the resize? Why won't you let me resize? Hello? Why can't I? There we go. That works. That did not. I didn't grab it. There we go. There we go. It's still a little bit big, but it works. So if we close this, and we're going to get the calculator back. Okay, let's see. Here. We're gonna print. Let's see. So 11,467. That's 13. So we're gonna have to increase by 11. So now we should be able to do print index. Nope. Print index. Uh, 11,468. And that should be what is it? It'd help if we type word list 11,468. That's in the way. This could come over here. Crap, where's my thing? I think I might have left it upstairs again. Which sucks. Oh, I gotta blow my nose. Hold on. Oh no, I didn't mute. Alright, I'm good. So now we print that. It's A, so it works. And I'm actually gonna get rid of this. There we go. So now we add where's the calculator go? There it is. So then we add 11,468 to that. And then index 22,922 should be I can't remember what it is. Print index Nope. Index. 22,922. That is not right. 20,922. And then do that, and then that. And we go word list. 22,922. That's not right again. 922. And go. Zounds. It should be Zounds. Zounds and... Why aren't you happy? What? Because I included that. Go. See, look. It just capitalized the first letter. Now, we're gonna do the same thing again. So, I'm just gonna type it, I don't care. Print index. I did not. Index 20,923. And then do that. That's not right. And word list 22,923. And then we're gonna add. I'm gonna hit not that button, this button, just so we can do this. We're gonna add another 11,454. Go. I think I have too many words in the index. So, wait, what word was that? It was 34,376. Print index 34,736. That's gonna bug me. Is that right? No. I was close though. 376. There we go. Then like so, and then huh. That's a thing that I could do apparently. Word list 34,376. That should be zounds. If it's zounds, we have too many characters. What? It is zounds. Wait, no, it's nothing. It's a space. That makes sense. No, it doesn't. Yes, it does. Because it adds everything, which means there's two of the first 12, 13. There's two of the first 13. Dang. Forward and word list. Can I say 13 to 11,467. And that should fix my issue. It gave me a better number, which is good. Apparently there's zodiacs now. Did I not go far enough? I don't think I went far enough. Hold up. Wait a second. Zounds? Wait, what did I type in? 467? 467, yeah. Zodiac. What if I type in, say, like, 470? Which is too many. Because now it's printing A and abandon again. But this works. Huh. And now we're back into like the normal capitalization, and we could see, we check. Let's see, where does it start being here? Seal zounds, and then it goes straight to there, which is good. It's too many, so I won't. 13 to 468. Huh. And then this is one too little. Because it's printing Zodiac. Well, we fixed the issue of our word index being too big and having a whole bunch of duplicates. Because it just went through and it appears to be working just fine. This is not even what we're supposed to be working on today. We're supposed to be working on a Pytorch. I got sidetracked. And you're supposed to be 60. You're supposed to be 7. Which means you're supposed to be 7. And then that would work. Zounds, it works. Ha ha ha. So let's just. All of this is debugs. Let's just debug. There we go. Debug. There we go. Okay, let's save that. I've been doing some work on this. I still need to finish the actual course. I probably should just do that off stream from now, because we're gonna be working on Pytorch for a while. So let's go to the Pytorch. I've made a new program. Not a new program, I knew a file for it. So let's put you down here. Bring you over here, make you bigger. And go.
This example, we might have some input data which are images of food. And then we want our neural network to learn the representations between an image of ramen and an image of spaghetti. And then eventually we'll take those patterns that it's learned and we'll convert them into whether it thinks that this is an image of ramen or spaghetti. Or in the case of this tweet, is this a tweet for a natural disaster or not a natural disaster? So our neural network has, well, we've written code to turn this into numbers, pass it through our neural network. Our neural network has learned some kind of patterns, and then we ideally want it to represent this tweet as not a disaster. And then we can write code to do each of these steps here. And the same thing for these inputs going as speech, turning into something that you might say to your smart speaker, which I'm not going to say because a whole bunch of my devices might go off. And so let's cover the anatomy of neural networks. We've hinted at this a little bit already, but this is like neural network anatomy.
Oh crap. Oh no.
101.
Okay, I broke it. Hold up. Go.
Again, this is highly units. You can have, I put a S here because you can have one hidden layer, or the deep in deep learning comes from having lots, 100 computer vision algorithm, by the way. Lots of terms we're throwing out here, but /neuron is describing all of the layers combined. So that's when you hear neural network architecture, it talks about the input, the hidden layers, which may be more than one, and the output layer.
don't
So that's a
really
terminology for
do-
overall architecture. Now, I say patterns is an arbitrary term. You can hear embedding. Embedding might come from hidden layers. Weights, feature representation, feature vectors, all referring to similar things. So again, how do we turn our data into some numerical form, build a neural network to figure out patterns to output some desired output that we want? Why is all patterns in our data? We'll see all. We've discussed a brief overview of an anatomy of arms. So the first one is supervised learning, and then we have unsupervised and self-supervised learning, and transfer learning. Now, supervised learning is when you have data and labels, such as in the example we gave at the start, which was how you would build a neural network or a machine learning algorithm to figure out the rules to cook your Sicilian grandmother's famous roast chicken dish. So in the case of super inputs to those. And self-supervised learning is you just have the data itself. You don't have any labels. So in the case of cat and dog photos, you only have the photos. You don't have the labels of cat and dog. So in the case of between data itself. And then finally, transfer learning is a very, very important paradigm in deep learning. It's taking the patterns that one model has learned of a data set and transferring it to another model, such in the case of if we were trying to build a supervised learning algorithm for discerning between cat and dog photos. Start with a model that has already learned patterns and images and transfer those foundational patterns to our own model so that our model gets a head start. Transfer learning is a very, very powerful technique.
There you go.
But as for this course, we're going to be writing code to focus on these two, supervised learning and transfer learning, which are two of the most common paradigms or common types of learning in machine learning and deep learning. However, this style of code, though, can be adapted across different learning paradigms. Now, I just want to let you know there is one that I haven't mentioned here, which is kind of in its own bucket, and that is reinforcement learning. So I'll leave this as an extension if you wanted to look it up. But essentially, this is a good one. This is a good photo, actually, so shout out to Katie Nuggets. The whole idea of reinforcement learning is that you have some kind of environment and an agent that does actions in that environment, and you give rewards and observations back to that agent. So say, for example, you wanted to teach your dog to urinate outside.
He listed to a full course.
You would reward its actions of urinating outside and possibly not reward its actions of urinating all over your couch. So reinforcement learning is, again, it's kind of in its own paradigm. This picture has a good explanation between unsupervised learning, supervised learning to separate two different things, and then reinforcement learning is kind of like that. But again, I will let you research the different learning paradigms a little bit more in your own time. As I said, we're going to be focused on writing code to do supervised learning and transfer learning. And how'd you go? Did you do things or machine learning and to number? The reason one of machine learning is if you don't need it, you don't use it. But if you do use it, it can be used for learning. We've got a programming contract. You don't recommend learning as well. But assistant to say is street. Same as this, you have a sequence section that it's more than one thing or another, and this in learning. From pre-processing data, getting then in your...
I didn't break it.
Is essentially very fast at crunching numbers. Originally designed for...
Okay.
Tensor. This is probably my favorite video on what is a tensor by Dan on what is a question.
Okay, hold up. Just start coding so I can start learning. I don't need a history lesson. If I want a history lesson, I'll look at my own history lesson.
So say we were working on image classification, neural network. Are you waiting?
I mean, this is all really good. It's good, it's a good video because he's going into detail like this, and you might won't detail like this, and sometimes you
start
need
discussion. And then
detail
someone,
like this.
Either myself or someone else from the course will be able to help out there. And the beautiful thing about this is that it's all in one place. You can start to search it. There's nothing here yet because the course isn't out yet, but as you go through it, there will probably be more and more stuff here. Then if you have any issues with the code that you think needs fixed, You can also open a new
Okay,
issue
he's gonna
there.
link his
I'll let
code
you read more into what's going on. I've just got some issues here
in the
already
description.
about
It
the
looks
fact that I
like,
need
which
to
is
record
good.
videos for the course. I need to create some
I
stuff.
could go get that
The course.
if I need it.
So here we can go print. Hello, I'm excited to learn Pytorch. And then if we hit Shift and Enter, it comes out like that. But another beautiful benefit of Google Colab, PS, I'm using the Pro version, which costs about $10 a month or so. That price may be different depending on where you're from. The reason
I
I'm
am
doing that is I
using
use Colab all
Visual
the time.
Studio.
However, you do not have to use the paid version for this course. Google Colab comes with a free version, which you'll be able to use to complete this course. If you see it worthwhile, I find the Pro version is worthwhile.
Okay.
Another benefit of Google Colab is if we go here, we can go to runtime. Let me just show you that again. Runtime, change runtime type, hardware accelerator, and we can choose to run our code on an accelerator here. Now we've got GPU and TPU. We're going to be focused on using GPU.
I don't just start coding, dude.
We're going to print torch ... version. So that's another beautiful thing about Google Colab is that it comes with Pytorch pre-installed and a lot of other common Python data science packages, such as we could also go import pandas as PD, import numpy as np, import matplotlib dot pyplot as plt. This is Google Colab is by far the easiest way to get started with this course. You can run things locally. If you'd like to do that, I'd refer to you to Pytorch Deep Learning. There's going to be setup.md. Getting set up to code Pytorch. We've just gone through number 1, setting up with Google Colab. There is also another option for getting started locally. Right now, this document's a work in progress, but it'll be finished by the time you watch this video. This is not a replacement, though, for the Pytorch documentation for getting set up locally. So if you'd like to run locally on your machine rather than on Google Colab,
that's what I'm doing. Is running it locally
or setup.md here. But if you'd like to get started as soon as possible, I'd highly recommend you using Google Colab. In fact, the entire course is going to be able to be run through Google Colab.
Hold on, let me see.
Let's finish off this video. Make sure we've got Pytorch ready to go.
You stop for a minute. Let me check. Does he have the Google Colab link in his description? Because if he does, this is gonna make go. No. Oh, I need to have. Oh, okay. Hold on. You had this collab. Okay. Do you have it in your description? Does not appear to be in the description. Oh well. That sucks. Okay. You can continue.
And of course, some fundamental data science packages here. Wonderful. This means that we have Pytorch 1.10.0. So if your version number is far greater than this, maybe you're watching this video a couple of years in the future and Pytorch is up to 2.11, maybe some of the code in this notebook won't work. But 1.10.0 should be...
Hold up. Maybe we should, Actually, can't I just check the Pytorch website? I just downloaded this yesterday. We're on version... something. 2.2.0. I believe. So, yeah, that might be an issue. Hopefully it all works. Fingers crossed. I don't need the Pytorch website. Pytorch.org. Chat, someone might need to remind me Pytorch.org. But if we need that, we'll get it. So let's go here.
More than enough for what we're going to do. And plus CU111, CU111, stands for CUDA version 11.1, I believe. And what that would mean is if we came in here and we wanted to install it on Linux, which is what Colab runs on. There's Mac and Windows as well.
We're a little bit in the future.
Yeah. So right now, as of recording this video, the latest Pytorch build is 1.10.2. So you'll need at least Pytorch 1.10 to complete this course, and CUDA 11.3. So that's CUDA Toolkit.
Hopefully it'll work for me because I'm at Pytorch 2.2.
Is NVIDIA's
I believe.
Programming.
You know what?
There we
I'm
go.
actually just going to reprint that
NVIDIA
off.
developer. CUDA is what enables us to run our Pytorch code on NVIDIA GPUs, which we have access to in Google Colab.
Version.
Beautiful. So we're set up, ready to write code. Let's get started in the next video writing some Pytorch code.
Yeah,
this is so exciting.
We're good.
I'll see you there.
We're
So
good.
we've got set up. We've got access to Pytorch. We've got a Google Colab instance running here. We've got a GPU because we've gone up to runtime, change runtime type, hardware accelerator. You won't necessarily need a GPU for this entire notebook, but I just wanted to show you how to get access to a GPU because we're going to be using them later on. So let's get rid of this. And one last thing, how I'd recommend going through this course is in a split window fashion. So, for example, you might have the video where I'm talking right now and writing code on the left side, and then you might have another window over the other side.
That's kind of what I got going on. I got the video in like a mini player. I also have it open over here, and if I need help, I also have ChatGPT and Twitch chat. But there's like, let's see, how many people are here? There's one person here. To be fair, one person could do amazing things. I only had one person during the last stream, and they were very, very helpful. I do not think I would have made as much progress as I did in the last stream without them, so thank you. But, yeah, so one person could be a lot. But ChatGPT here is also, and they got the video in the mini player and over here on my other monitor, and then I have just Visual Studio stuff over there, so we're good.
With your own Colab window, and you can go new notebook,
Old.
call it whatever you want. My notebook, you could call it very similar to what we're writing here. And then if I write code over on this side, this video, you can't copy it, of course, but you'll write the same code here and then go on and go on and go on. And if you get stuck, of course, you have the reference notebook and you have an opportunity to ask a question here. So with that being said, let's get started. The first thing we're going to have a look at in Pytorch is an introduction to tensors. So tensors are the main building block of deep learning in general, or data. And so you may have watched the video, what is a tensor? For the sake of this course, tensors are a way to represent data, especially...
Stop. ChatGPT. What is a... And that's, yeah, he's gonna give me a... I was just gonna get like a short little thing. But that's actually, you know,
multi-dimensional data. Numeric data, that is. But that numeric data represents something else. So let's go in here, creating tensors. So the first kind of tensor we're going to create is actually called a scalar. I know I'm going to throw a lot of different names of things at you, but it's important that you're aware of such nomenclature. Even though in Pytorch almost everything is referred to as a tensor, there are different kinds of tensors. And just to exemplify the fact that we're using a reference notebook, if we go up here, we can see we have importing Pytorch. We've done that. Now we're up to...
Hold up. I think actually he does have that one. The Pytorch fundamentals. Does he have that one? Because if he has that one, I want to open. Maybe it's this one. Open link a new tab. Oh, yep, he has it. Let's go. So now I have his notebook. His this thing open. Yeah. Import pytorch.io. And learn pytorch.io. So yeah. If I need something, I can just come over here and get it. That's good.
To introduction to tensors. We've got creating tensors, and we've got scalar, etc., etc., etc. So this is what we're going to be working through.
There's a lot of tensors.
Let's do it together. So scalar, the way to... Oops, what have I done there? The way to create a tensor in Pytorch, we're going to call this scalar equals torch.tensor, and we're going to fill it with the number 7. And then if we press or retype in scalar, what do we get back? 7. Wonderful. And it's got the tensor data type here. So how would we find out about what torch.tensor actually is? Well, let me show you how I would. We go to torch.tensor. There we go. we've got the documentation. So this is possibly the most common class in Pytorch, other than one we're going to see later on that you'll use, which is torch.nn. Basically, everything in Pytorch works off torch.tensor. And if you'd like to learn more,
well, actually, I like my variables
read through
capitalized.
here. In fact, I would encourage you to read through this documentation for at least 10 minutes after you finish some videos here. So with that being said,
I don't
I'm going
want
to link that in here.
That's
so
fine if I don't read
PyTorch
that.
tensors are created using torch.tensor. And then we've got that link there. Oops. Typos galore, Daniel. Come on. You're better than this. No, I'm kidding. There's going to be typos galore through the whole course. Okay. Now, what are some attributes of a scalar? So, some details about scalars. Let's find out how many dimensions there are.
I'm going to leave you open.
Oh, and by the way, this warning, perfect timing. Google Colab will give you some warnings here, depending on whether you're using a GPU or not. Now, the reason being is because Google Colab provides GPUs to you and I for free. However, GPUs aren't free for Google to provide. So if we're not using a GPU, we can save some resources, allow someone else to use a GPU by going to none. And of course, we can always switch this back. So I'm going to turn my GPU off so that someone else out there, I'm not using the GPU at the moment, they can use it. So what you're also going to see is if your Google Colab instance ever restarts up here, we're going to have to rerun these cells. So if you stop coding for a while, go have a break, and then come back and you start your notebook again, that's one downside of Google Colab, is that it resets after a few hours. How many hours? I don't know exactly. The reset time is longer if you have the Pro subscription, but because it's a free service and the way Google calculates usage and all that sort of stuff,
hold on. Crap, broke it
I
again.
can't give a conclusive evidence or conclusive answer on how long until it resets.
Just you go over
just
there.
know, if you come back, has no new scale tensor, give it back, number out. But then if you come conclusive evidence service and the way Google calculate usage and all that sort of stuff,
hold on. Please
I can't give a conclusive evidence or conclusive answer on how long until it resets.
Wait, hold on.
But just know, if you come back...
Oh, this endium is just how he's checking the, check the dimensions of a tensor. That seems important. I'm just gonna go ahead and do scalar dot endium. I accidentally turned on caps lock. Here we go. And does that actually do anything? Why did it do this? It always takes a second to run the torch stuff. Okay. I guess we should probably print that so you can see what it says. Print. It would help if I write correctly. There we go. Yep, 0. Okay. Let's just do it like this. No, let's not. Delete. Let's 0, just like I said. Don't think I need that. Next, I'm gonna get the number with a tensor. Only works with one element tensors. Get the Python number within the tensor. So, okay, hold on. Let's actually
back. You might have to rerun some of your cells, and you can do that with Shift and Enter. So a scalar has no dimensions, right? It's just a single number. But then we move on to the next thing. Or actually, if we wanted to get this number out of a tensor type, we can use scalar.item. This is going to give it back as just a regular Python integer. Wonderful. There we got the number 7 back. Get tensor back as Python int. Now, the next thing that we have is a vector. So let's write in here, vector. which again is going to be created with torch.temp.
Okay, hold up. We're just gonna... I mean, I know what I said. I'm gonna rewrite it. So we could... print... scalar... print... I think I'm gonna leave this here just so I can refer to it and hopefully understand it better. Scalar dot indium, and then we could say I broke it. There we go. Then we could get scalars int print scalar dot item like so, and then we're going to start with here we have the scalar, and down here we're going to have the vector. And then if we run it, it's kinda, it kinda takes a second to run Torch. It has that really long startup. Whereas if we say run, this, it's just gonna go. Okay.
Tensor, but you will also hear the word vector used a lot too. Now, what is the deal? Oops, 7.7. Google Colab's autocomplete is a bit funny. It doesn't always do the thing you want it to. So if we see a vector, we've got two numbers here. And then if we wanted to find out what is a vector, so a vector usually has magnitude and direction. So what we're going to see later on is, there we go, magnitude, how far it's going and which way it's going. And then if we plotted it, we've got, yeah, a vector equals, the magnitude would be the length here and the direction would be where it's pointing. And, oh, here we go. Scalar, vector, matrix, tensor. This is what we're working on as well. So the thing about vectors, how they differ with scalars, is how I just remember them, is rather than...
That picture made it look like a tensor is a vector of... Hold on. Can we go back just a second? Let's go here, and I'm just going to do this. Because...
About vectors, how they differ with scalars, is how I just remember them, is rather than magnitude and direction, is a vector typically has more than one number. So if we go vector and dim, how many dimensions does it have? It has one dimension, which is kind of confusing, but when we see tensors with more than one dimension, it'll make sense. Confused dimensions does it have?
Okay, okay, I don't think I'd rewound that back right. So, yeah, but it looked like, hold on, let me just get the name of the next one, because it looked like there's only 4. So it looked like the, tensor was a matrix, that was the other one. Looked like a matrix, a vector of matrices, and a matrix is multiple vectors, so it's a vector of the vectors for a vector. At least that's what the picture later looked like. I could just be explaining this like crap. And then no one in chat knows what I'm talking about, and they just like all think I'm crazy. That's a very big possibility. Oh. Oh no, we have not been here. What? Okay, it's only 45. That's about 10 minutes ahead, right? How's it already been 45 minutes? I've written 11 lines of code. And multiple are empty. Okay, let's get the tab back up. Not this one. This one. Okay, so let's go here and say number of... How does one spell dimensions? That's how one spells dimensions. Dimensions and scale. Then we're just gonna steal this line, go down here and put it there. We're just gonna change this for vector. I'm gonna change this for vector. And let's put this over here for a second, and we could run that, and it's gonna be slow. Yeah, see? We're actually gonna put a break, too. Kill the terminal. That way it'll look a little bit easier to read. Okay, print vector. Yeah, oh, look, it's even printing Tensor. I didn't realize that. Okay. Let's get you back. Let's shrink you back down a little bit. And go.
It has one dimension, which is kind of confusing, but when we see tensors with more than one dimension, it'll make sense. And another way that I remember how many dimensions something has is by the we go vector square brackets, and when I say, so the different
shape?
Shape is 2. So the difference between dimension, so dimension is like number of square brackets, and when I say, even though there's 2 here, I mean number of pairs of closing square brackets. So there's 1 pair of closing square brackets here, but the shape of the vector is 2. So we have 2 by 1 elements. So that means a total of 2 elements. Now, if we wanted to step things up a notch, let's create a matrix. So this is another term you're going to hear, and you might be wondering why I'm capitalizing.
Hold on, I could always just come back over here. Vector shape, the same as vector. Did not do that right. Shape. And we can run that. Yeah. And it keeps putting that like right on to the next line, so I'm actually just gonna print. I'm just gonna print, just so I have a line break in between the bottom and the end without having to type in that backslash in. So yeah, this does make it a little bit easier to read. There we go. So then I'm also gonna get. So, gee, item won't work, would it? Okay, let's continue.
Matrix. Well, I'll explain that in a second. Matrix equals torch.tensor, and we're going to put 2 square brackets here. You might be thinking, what could the 2 square brackets mean? Or actually, that's a little bit of a challenge. If 1 pair of square brackets had an ndim of 1, what will the ndim be? Number of dimensions of 2 square brackets. So let's create this matrix. Beautiful. So we've got another tensor here.
Matrix.
Again, as I said, these things have different names, like the traditional name of scalar,
Torch.
vector, matrix, but they're all still a torch.tensor. That's a little bit confusing, but the thing you should remember in Pytorch is basically anytime you encode data into numbers, it's of a tensor data type. And so now, how many number of dimensions do you think a matrix has? It has 2. So there we go, we have 2 square brackets. So if we wanted to get matrix, let's index on the 0th axis. Let's see what happens there. So we get 7 and 8, and then we get off the first dimension. 9 and 10. So this is where the square brackets, the pairings come into play.
Hold up. Wait there. Let me get caught up a bit. So we're down here now. I think I still have this line copy pasted. Yep. And matrix. Got the art. Matrix. Oh gosh, I suck at typing. Hold on. Dang it. Go. And then I'm gonna go ahead and print. Okay, hold up. I'm just gonna leave it.
We've got 2 square bracket pairings on the outside here, so we have an ndim of 2. Now if we get the shape of the matrix, what do you think the
I am actually gonna print these, so let's type in print. Print. Index. Print. One. Matrix. 1. 2. 0. Yeah. 0. Copy. Undo. Copy. Print. And I'm gonna go all the way to 2, and it's probably gonna break. Do 1. 1. 2. 2. Yeah, it broke. Because 117. It's not. Okay, head up. Something like that. Run. And now this is gonna work. No! Why did it not work? Hold up. Why is it not working? He just typed in matrix bracket 1. Yeah, that is our brackets. Definitely brackets. Why is it not working? For me. Let's look over here, towards side, because matrix. Alright, let's see what you have to say. Vector shape, torch size 2, number of dimensions in vector. That's for the last one. I never. Hold up. The matrix is broken. Why is the matrix broken? So this line is messed up. But why? Why are you broken? That's a very good question, Parker. I do not know the answer to that. But I would like to know the answer to that. And I don't know the answer to that. And let me just... They have a, thing. Here. Not there. They have a thing here. Let's see if that helps. No. Still broken. Doesn't like that. Why does it not like that? I see. Hold up. I see. We do that. We do that. And will that work like this? Which means this also means I was right the first time. So let's just... No, it'll work like that. Would it work like... Not like that. I guess it is like that. Okay. Oh well. Hold up. So... Are we good now? We're good. It works, which means I could actually try to, copy and paste, and then just change this one to 2. If it works and does something, it's gonna break. What? Yep, it broke. Okay. Alright. Next we could print the print matrix shape matrix dot shape and go. And I'm also going to put a break here, because that needs a break. Okay, let's go here. This, and then it's going to be like that. And after the shape, we're going to be onto tensor, so we can put a line break here as well. And then we print, and it'll work. And look at that. 0, 1. And it prints each of that, and the shape is 2, 2. But let's say if I were to add, say, 11 to this, would that be 2, 3? No, it's gonna break. Because we can only hold a link of 2? Why can it only... Fascinating. Interesting. So it breaks it. It can only take it 2. 2 elements deep and 2 element... Hold on. We get outputted torch size 2, 2, because matrix is 2 elements deep and 2 elements wide. So it can only hold 2, and then you could print each row. Hold on, let me just skip forward a bit. Tensor shape. Tensor shape. 1 would up. Okay, hold on. Let me get caught up here. So let me just go. Tensor. And then I got an itch. Hold up. There we go. Let me get a second. my wrist just popped. When I closed my cup. Oh, tensor's also capitalized. So let's. I should help if I can. Tensor. Right? Yes. Equals. Torch. Torch dot. Tensor. And then it's 3 brackets. Wait, what? Why is it? So it's 1, 2, 3. And then they have 1, 2, 3. Three, 6, 9. 6, 9. And then 2, 4, 5 is what they have entered. I am just copying these numbers because I'm learning and it really does not matter. I don't want my outputs to be the same as the class. Because this seems really complicated. I just got a notification. But that's fine. I gotta reposition myself. Okay, where were we? Oh yeah, you should probably be finished it. I'm getting ahead of the guy.
2 by 2. So we've got 2 numbers here by 2. So we have a total of 4 elements in there. So we're covering a fair bit of ground here, nice and quick, but that's going to be the teaching style of this course, is we're going to get quite hands-on and writing a lot of code and just interacting with it rather than continually going back over and discussing what's going on here. The best way to find out what's happening within a matrix is to write more code that's similar to these matrices here. But let's not stop at matrix. Let's upgrade to a tensor now. So I might put this in capitals as well. And I haven't explained what the capitals mean yet, but we'll see that in a second. So let's go torch.tensor. And what we're going to do is this time we've done 1 square bracket pairing. We've done 2 square bracket pairings. Let's do 3 square bracket pairings and just get a little bit adventurous, all right? And so you might be thinking at the moment, this is quite tedious. I'm just going to write a bunch of random numbers here. 1, 2, 3, 3, 6, 9, 2, 5.
He says they're random, but he's copying the course too.
Thinking, Daniel, you've said tensors could have millions of numbers. If we had to write them all by hand, that would be quite tedious. And yes, you're completely right. The fact is, though, that most of the time you won't be crafting tensors by hand. Pytorch will do a lot of that behind the scenes. However, it's important to know that these are the fundamental building blocks of the models and the deep learning neural networks that we're going to be building. So, tensor, capitals as well. We have 3 square brackets. So, or 3 square bracket pairings. I'm just going to refer to 3 square brackets at the very start because they're going to be paired down here. How many ndim or number of dimensions do you think our tensor will have? 3, wonderful. And what do you think the shape of our tensor is? We have 3 elements here, we have 3 elements here, 3 elements here, and we have 1, 2, 3. So maybe our tensor has a shape of 1 by 3 by 3. What does that mean? Well, we've got 3 by 1, 2, 3. That's the second square bracket there. By 1. So that's the first dimension there, or the 0th dimension, because remember, Pytorch is 0 indexed. We have, well, let's just, instead of talking about it, let's just get on the 0th axis and see what happens with the 0th dimension. There we go. Okay.
Okay, I'm going to go ahead and print all of it. The tensor shape is going to be equal to tensor dot. Hey, we're going to go over here, and we're going to leave that at the end. And then just do our line break, and we're going to go over here, and we're going to go print index print. And since we're just doing that, I'm gonna hold up. Print tensor. I'm gonna print it like that, and we're just gonna copy. Go 0, go 1, and we can go 0, we can go 1, like 4, I'm going to go down to 2, so we can go 2, I'm going to go to here and print it to the breaks. So now let's print that. It broke. Why did you break? Because it should work. It broke at 1. Hold up. Delete all that, but we print this, and it prints the whole thing. Fascinating. Go.
So this is the far left one, 0, which is very confusing because we've got a 1 here. But, so we've got, oops, don't mean that. What this is saying is we've got one 3x3 shaped tensor. So, very outer bracket matches up with this, number 1
We
here.
have that thing,
And then this
thing,
3
right? Yeah.
matches up with the next one here.
What happens
which
for her
is
to say
1, 2, 3. And then this 3 matches up with this one. 1, 2,
just gonna break it?
3. Now, if you'd like to see this with a pretty
Did.
picture, we can see it here. So, dim 0 lines up. So the blue bracket, the
has
very
to be a
outer
square.
one, lines up with the 1. Then dim equals 1. This one here, the middle bracket, lines up with the middle dimension here. And then dim equals 2. The very inner lines up with these 3 here. So again, this is going to take a lot of practice. It's taken me a lot of practice to understand the dimensions of tensors, but
I
to
get it. I
practice,
get it. I get it. I get it. I
I would
get it. I
like-
get it. I 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 get it. Let me just hey, Mr. Video Man, go back. Go back. Yes, that's perfect. So let's do this. Okay, so I get why there's so many brackets now, and why it keeps breaking, because the dimensions are, they all have to be the same size. So it's always going to be a square, and this is where the matrix broke when I tried to add another one. So it didn't add another one to both. So if I add another one to both, I bet you that matrix is going to work as well. If I add another one to all 3 of the tensor, I bet you all those are going to work too. So the first one just says there is one thing. There's like one whole big thing. And then the second one says there is 3 groups. And the third one says all of the groups are this long. I get it. Alright, you could get much smaller now. You know, hold on, how does Twitch like that? I'm curious what my bitrate does when I do that. Let's go here. Oh. So, whoop. Oh, it doesn't really care. Yeah, it really doesn't care. I believe the bitrate is just like how much it actually has to change. But yeah, Twitch performance does not care if I start changing the whole, if I start just making that get crazy.
Understand
Alright,
the
let's continue.
dimensions of tensors, but to practice, I would like you to write out your own tensor of, you can put however many square brackets you want, and then just interact with the endim, shape, and indexing, just as I've done here, but you can put any combination of numbers inside this tensor. That's a little bit of practice before the next video. So give that a shot, and then we'll move on to the next topic. I'll see you there. Welcome back. In the last
Okay, so this whole course just seems like one big thing. Oh, yeah. Ugh, excuse me. And the matrix shape is, says there... Hold on, let's go back here. So the matrix shape, where is it? Here it is. 2, 2. It says there's 2 groups of 2. Wait, does that mean I can make that first number 1 if I were to say go here and what if I just and it's gonna break? Maybe. No. So now it says the shape is there's 2 groups, 2 squares, both 3 by 3. 2 squares, 3 by 3. But what if I make 1 square 4 by 4? So, or this is gonna bug me. 12. Fix it over here because it's annoying. Get rid of this. And 10, not 120. 10. Yeah, and then add another group. Let's say 1, 3, 2, 4. And now what happens? Is it gonna break? Then it's gonna break. If I get rid of all this though, then it's gonna be 144. Then it's gonna be 144. Okay, I got it. I got this. Let's just reset all of that. Okay, let's bring this back over here and continue.
last video, we covered the basic building blocks of data representation in deep learning. Within to get as creative as you like with creating your own tensor. So I hope you gave that a shot, because as you'll see throughout the course and your deep learning journey, a tensor can represent or can be of almost any shape and size and have almost any combination of numbers within it. And so this is very important to be able to interact with different tensors, to be able to understand what the
This is gonna be a long
names
course.
of things are. So when you hear matrix, you
Wait,
go,
hold
oh,
up.
maybe that's a
We're an
two-dimensional
hour and 36
tensor.
minutes into this
When you hear a
video.
vector, maybe that's a one-dimensional tensor. When you hear a tensor,
Actually,
that could be any amount of dimensions.
we're
And
doing
just for
pretty
reference
good.
for
We're
that,
only an hour
if we come
14
back to
into the
course
stream.
reference, we've got a scalar. What is it? A single number.
I
Number
did
of
give myself a
dimensions,
30-minute
0.
head start, though.
We've got a vector, a number with direction, number of dimensions, 1. A matrix, a tensor. And now, here's another little tidbit of the nomenclature of things, the naming of things. Typically, you'll see a variable name for a scalar or a vector as a lowercase. So a vector, you might have a lowercase y storing that data. But for a
Okay.
matrix or a tensor, you'll often see an uppercase letter or variable in Python in our case, because we're writing code. And so I'm not exactly sure why this is, but this is...
I normally, for my variables, I normally use words, not single letters. And I normally just capitalize everything. So it's just, I'm not sure why this is. Let's see if this course has anything to say about it. Let's skim through it here. We're still in the... There's a cheat sheet, extra resources, quick Pytorch 2.0 tutorial. There's another tutorial for 2.0. Okay, 3 most common errors in Pytorch. We need to do the Pytorch class, then we need to go back to the Burt class. First, I need to finish building that GPU. So I'm probably gonna finish building that GPU off stream, and then we can continue on Pytorch for stream. I'm gonna schedule myself more coding because I'm having a lot of fun with this. All right, let me just skim through this. Random sense. Does it say anything? It does not. Okay, you can continue.
It's just what you're going to see in machine learning and deep learning code and research papers across the board. This is a typical nomenclature. Scalars and vectors, lowercase, matrix and tensors, uppercase. That's where that naming comes from. And that's why I've given the tensor uppercase here. Now, with that being said, let's jump in to another very important concept with tensors, and that is random tensors. Why random tensors? I'm just writing this in a code cell now. I could go here. This is a comment in Python. Random tensors. But we'll get rid of that. We could just start another text cell here, and then 3 hashes is going to give us a heading. Random tensors there. Or I could turn this again into a markdown cell with command MM when I'm using Google Colab. So random tensors. Let's write down here. Why random tensors? So we've done the tedious thing of creating our own tensors with some numbers that we've defined, whatever these are. Again, you could define these as almost anything. But random tensors is a big part in Pytorch because, let's write this down. Random tensors are important because the way many neural networks learn is that they start with tensors full of random numbers and then adjust those random numbers.
Okay, I do know this. Like, the way neural networks, they are very stupid when they start out. Like, an untrained monkey would be a better suit for the job than a new neural network. So what you do is you have it work alongside something that's actually smart. Like, I'm pretty sure most like neural networks on the internet or something, not the internet. This is probably a bad example, and I'm probably really wrong about this. So do not quote me on this, but this is my guess. Is like someone probably worked alongside, like a human worked alongside that neural network for a bit, or they just kind of had it run in the background and not do anything and study for a bit before they actually let it do its own thing. And then once it was allowed to do its own thing, it's just slowly made little tweaks. But at the start, the neural networks, I do know this, are all very stupid. And they just do whatever the heck they want. Like, I feel like this is a 1, 0, 1. Let's do another 1. Let's do 5 more zeros and 2 more 1s. Just like all sorts of stupid. But after a little bit, it's going to be like, oh, doing a 0 here is a very, very bad idea because it is. So let's do a 1. So they get smarter. That's the whole point of machine learning. And why... So they do get smarter.
To better represent the data. So seriously, this is one of the big concepts of neural networks. I'm going to write in code here, which is this is what the tick is for. Start with random numbers. Look at data. Update random numbers. Look at data. update random numbers. That is the crux of neural networks. So let's create a random tensor with Pytorch. Remember how I said that Pytorch is going to create tensors for you behind the scenes? Well, this is one of the ways that it does so. So we create a random tensor, and we'll give it a size of, random tensor of size or shape. Pytorch use these independently. So size, shape, they mean they're different versions of the same thing. So random tensor equals torch dot rand, and we're going to type.
Okay, so let's see, where is death? So we can put our size. Okay, hold up. So let's just type in random tensor equals torch dot rand size equals 3, 4. That's not right. 3, 4. And then don't know what that D type. Why are you stuck? Thank you. My mouse just got like a whole bunch of. Hold up. Okay,
type in here 3, 4. And the beautiful thing about Google Colab as well is that if we wait long enough.
Stop. We're gonna. Index 0 just prints the tensor, right? This one didn't print the tensor. Okay, what's the thing that just prints the tensor? Because I want to see it. This one print. It just print. Okay, so print random tensor. Okay, you could see that it did actually randomize it. I'm gonna print just to give it an extra break. And then we're gonna print. That's not right. Print. This is probably gonna be a good thing to like work on a little bit off stream too, but most of my learning probably will be off stream because I think it'll be like a very interesting journey. And unless the stream does terribly, then I won't do it. Sir, there we go.
Enough, it's going to pop up with the doc string of what's going on. I personally find this a little hard to read in Google Colab because you see you can keep going down there. You might be able to read that. But what can we do? Well, we can go to torch.rand. Then we go to the documentation. Beautiful. Now, there's a whole bunch of stuff here that you're more than welcome to read. We're not going to go through all that. We're just going to see what happens hands-on. So, we can copy that in here. And
wait, does this torch? So, if rand size sequence, I wonder. Since it just tells me what's kind of going on. Wait a second. So this is like what's... This is the, I believe C code that's going in behind... Because Python's built on top of C, if I remember correctly. Is this, like, what's going on behind the scenes? In the C code, and then we just... Wait, isn't index a variable I made? That's a dot index. So no, it's not. What if find all? Power string. Okay, no, wait. It's, I think it's breaking down. Wait, I don't know. I thought I knew what that was. I just probably sound like an idiot. Because I'm in way over my pay grade. I am not qualified to do this. At all. Like, at all, at all. Like, at all, at all, at all. Like, I'm probably the least qualified person ever to be doing all this. I've only been using Python for like a week. I've been coding in Java. I never did anything this complex in Java because whenever I needed to do something in Java, it's always like, if I just want, look, in Python I could just type in input. I could just say string equals input print string, and I could run it, and I could say hello world, and it'll print hello world. It's simple in Python, but in order to do that in Java, I need to go. I'm just gonna comment this so it doesn't start yelling at me. Import. Oh crap! Let's see if I remember. Java dot until dot scanner, and then I'll do a semicolon, and then it's what is it? I got rid of all my old code because there's nothing in there. There's nothing important. This code I'm probably gonna keep. This Java, not import. It's scanner equals new scanner. No, that's not right. New scanner. Right? That's not right either. Crap, hold on. Do I have some of my old code that I could open for a demonstration? I do. Hold up. Eclipse. There we go. That's gonna load. Oh yeah, it's like a whole bunch. I'm gonna show y'all. I forgot to write too much. 3 and 4. You can
Right,
continue
some
on.
notes. Torch random tensors. Done. I'm just going to make some code cells down here so I've got some space. I can get this a bit up here. Let's see what our random tensor looks like. There we go. Beautiful.
I think Eclipse
Of
needs to
size
update.
3, 4. So we've got 3
Ah!
or 4 elements.
Eclipse did not need to update that much. Why is it over there? Open file. Desktop. Code. Java. This one? No. No. Hold up. Go here. Desktop. Code. Java. This one. No. Where is my old 3. Hold up, where'd my things go? I had things. Oh wait, here they are. No, I don't. My things are gone. Oh wait, here's the input class. Okay, here we go. This is actually a good one for y'all. Let's move this out of the way because it's just gonna be the way. Yeah, look. So you have to write all this stuff out. You gotta define the class. You gotta define the thing. This I don't know what this. Like the main thing you run, and you java.until.scanner, and you got go scanner equals. You don't have it doesn't have to be scanner. It could just be like s. It could say like scanner s equals new scanner system.in, and then you gotta just say scanner dot next line or next int, and it can only string. It can only input accept an int. And can I add this to my dictionary? Do not see that. But yeah, so it's a lot more complicated. Like also, we got. I know what this is. Why is the scanner broken? Sometimes it does this too. Yeah, but I had a friend Techie's been bugging me about switching to Python for a while, and I finally gave in, and I'm so glad I did because this is so much easier. Because I don't need to import 700 things to do anything complicated. Like, I probably needed to have 3 other things imported for this. And I'm probably going to have like another 4 things imported to get anywhere close to this. And in this, I could just go. It's great. I love being able to just hop in and go. Alright, let's continue.
Elements here. And then we've got 3 deep here. So again, there's the 2 pairs. So what do you think the number of dimensions will be for random tensor? NDIM. 2.
Let's say random tensor 1. Because it looks like there's going to be... Hold up. Just looking over here, it looks like there's different types of tensor. So... I'm gonna leave this. I'm gonna have like all sorts of different random tensors. So as we go, I'm just gonna say random tensor 1, random tensor 2, and that sort of stuff. Then I'm gonna say, what was I gonna print? Hold up, I was gonna print something. I don't remember.
Beautiful. And so we have some random numbers here. Now,
I remember. Print number of dimensions random tensor dot ndim print shape random tensor dot shape and then like so. And we good? We good. An itch, hold up. There we go. And if I were to add, say, instead of change this from 3 to 4, what if I were to say put it as 7 to 5? And go. One, 2, 3, 4, 5, 6, 7, 5, and by 2. Okay. So, yeah, it can do that. I'll set it back to 3, 4. Oh.
Beautiful thing about Pytorch again is that it's going to do a lot of this behind the scenes. So if we wanted to create a size of 1010, in some cases we won't want one dimension here, and then it's going to go 1010. And then if we check the number of dimensions, how many do you think it will be now? 3. Why is that? Because we've got 1, 10, 10. And then if we wanted to create 10, 10, 10, what's the number of dimensions going to be? It's not going to change. Why is that? We haven't run that cell yet, but we've got a lot of numbers here.
Oh, I just missed what happened. Dang it.
We can find out what 10 times 10 times here be. It's not going to change. Why is that? 10. Why is that? And then in some cases, we're going to do... Now, the beautiful thing about Pytorch again is that it's going to do a lot of this behind the scenes. So if we wanted to create a size of 1010, in some cases we won't want one dimension here, and then it's going to go 1010. And then if we check the number of dimensions, how many do you think it will be now? 3. Why is that? Because we've got 1, 10, 10. And then if we wanted to create 10, 10, 10, what's the number of dimensions going to be? It's not going to change. Why is that?
Because it's still 3
We
dimensions.
haven't run that cell yet, but we've got a lot of numbers here. We can find out what 10 times 10 times 10 is. And I know we can do that in our heads, but
Oh, that hurt.
is we've got a calculator right here. 10 times 10 times 10. We've got 1,000 elements in there.
Stop,
But sometimes
stop,
tensors
stop,
can be
stop,
hundreds of
stop,
thousands of
stop.
elements.
Ow. My leg just cramped. I don't know why. But I do know it hurt. Holy crap, it hurts. Okay, let's continue. Ow.
Or millions of elements. But Pytorch is going to take care of a lot of this behind the scenes. So let's clean up a bit of space here. This is a random tensor. Random numbers, beautiful. Now it's got 2 dimensions because we've got 3 by 4. And if we put another 1 in the front there, we're going to have how many dimensions? 3 dimensions there. But again, this number of dimensions could be any number, and what's inside here could be any number. Let's get rid of that. And let's get a bit specific, because right now this is just a random tensor of whatever dimension. How about we create a random tensor with similar shape to an image tensor. So a lot of the time when we turn images, image size tensor, when we turn images into tensors, they're going to have, let me just write it in code for you first. Size equals a height, a width, and a number of color channels. And so in this case, it's going to be height, width, color channels. And the color channels are red, green, blue.
Hold up. I'm actually just gonna remove that. I'm just gonna steal that. Put it right there. Random image insert. We're gonna call it random image tensor equals torch dot rand and set the size to be 224 by 24 by 3. And then we're going to change this to random image tensor. Random image tensor. Random image tensor. And now if we run it, it's not printing the whole thing. Look. It's skipping like most of them. Which does kind of make sense. And there's skipping even more right here because it's going from whatever this one is, skipping most of the ones in the middle, and can go into this one. Which does make sense because there is only so much space that there is to print. But if I were to say just print, how about if I could type print random image tensor, say 5. It does print everything then. Everything. Okay.
Blue. And so let's create a random image tensor. Let's view the size of it or the shape. And then random image size tensor. We'll view the ndim. Beautiful. Okay, so we've got torch size, the same.
Okay, and they do something different for this one. They say, wait, hold up. No, they don't. It's still sensor.shape, sensor ndim. It's just the same thing. They just wrote it a little bit different.
Size 224, 224, 3. Height, width, color channels. And we've got 3 dimensions. 1 for height, width, color channels. Now let's go and see an example of this. This is the Pytorch Fundamentals notebook.
Excuse me.
If we go up to here, so say we wanted to encode this image of my dad eating pizza with thumbs up of a square image of 224 by 224. This is an input. And if we wanted to encode this into...
I believe it's actually 225, if I remember correctly. But of course there's that 0. Because that's where
tensor
the
format.
hurts.
Well, one of the ways of representing an image tensor...
If I'm wrong, feel free to just tell me in chat. Or if you're watching this on YouTube, just comment it in the VOD. I welcome feedback like that. I'm always excited to learn new stuff. To be honest, that's kind of why I'm doing this. It's just because, like, oh, that sounds cool. I want to learn it. No other reason. I have no goal for this. It's just so I could do it. It's just... I just want to... It's just going to be something that I could do.
Very common ways is to split into color channels, because with red, green, and blue, you can create almost any color you want. And then we have a tensor representation. So sometimes you're going to see color channels come first. We can switch this around in our code quite easily by going color channels here. But you'll also see color channels come at the end. I know I'm saying a lot that we kind of haven't covered yet. The main takeaway from here is that almost any data can be represented as a tensor, and one of the common ways to represent images is in the format color channels, height, width, and how these values are will depend on what's in the image.
This says color channels, height, width. This is width, height, color channels. So they're like... Theirs is more like this. Which to me makes more sense because you would have second. So there's 256 this way, and then there's 256 this way. Okay. I'm just gonna leave it like that. Oh no. Okay.
But we've done this in a random way. So the takeaway from this video is that Pytorch enables you to create tensors quite easily with the random method. However, it is going to do a lot of this creating tensors for you behind the scenes. And why are random tensors so valuable? Because neural networks start with random numbers, look at data such as image tensors, and then adjust those random numbers to better represent that data.
Give me a second, give me a second, give me a second. I was just looking ahead. It's using... Hold up. Okay. Okay, I'm good. I got what I wanted.
And they repeat those steps onwards and onwards and onwards. Let's finish this video here. My challenge for you is to create your own random tensor of whatever size and shape you want. So you could have 5, 10, 10 here. Let's see what that looks like. And
we already did that, chat. We were experimenting and we did that. Okay, let's see. How? Because if he's ending it off, I think we got time for like 3, 4 more. Yeah, I think we got time for 3 or 4 more. Let me go back to this.
Then we'll keep coding in the next video. I hope you took on the challenge of creating random tensor of your own size. And just a little tidbit here.
Actually, I'm going to make this one the last
one. In the previous video, I didn't use the size parameter. But in this case, I did here. You can go either way. So if we go torch.rand, size equals, we put in a tuple here of 3, 3. We've got that tensor there, 3, 3. But then also, if we don't put the size in there, it's the default. So it's going to create a very similar tensor. So whether you have this size...
Okay, I'm actually going to do random image as not having a size. Just so I know it works. Same thing.
Or not. It's going to have quite a similar output depending on the shape that you put in there. But now let's get started to another kind of tensor that you might see. Zeros and ones. So, say you wanted to create a tensor where that wasn't just full of random numbers. You wanted to create a tensor of all zeros.
Okay, then we're going to do... tensor all zeros and ones.
This is helpful for if you're creating some form of mask. Now, we haven't covered what a mask is, but essentially, if we create a tensor of all zeros, what happens when
zeros equals torch dot zeros to 3, 4. Then I'm gonna oops. I'm just gonna yoink this. I'm gonna call this one zero tensor. We have zeros tensor. Zeros. Number of dimension. Zeros. Zeros. There we go. So the shape of this one is like 3. Okay. The shape just seems, it's just like the input we're giving it. Pretty much. But this one is just 0. I can see there's another one in here called ones. That's why I said zeros and ones. Oh, they also said zeros and ones. So we can do ones equal to torch dot ones, and then do, say, 3, 4. And just paste that. Ones tensor. Ones. 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 There we go. There's also a new. It says zeros.data or D type. I did scroll through and that says, I believe that means data type, if I realized correctly. Yep, sensor data types. So we could go in here and add the print data. Oops. Data type. You could say zeros dot d type, and we could just go ahead and throw that in there too, and just change this to be ones, and we could run it. And I'm gonna add another break. Actually, no, it's fine. But yeah, so it's a float. What's float 32? Hold up. I'm getting a little bit ahead. There's 16-bit floating. Okay, wait, hold on. The default, I'm gonna read from this a bit. The most common type and generally default is torch.float32 or torch.float. This is referred to as 32-bit floating point, but there's also 16-bit floating point, torch.float16 or torch.half, and 64 floating point, which is torch.float64 or torch.double. And to confuse things even more, there's also 8-bit, 16-bit, 32-bit, and 64-bit integers, plus more. No integer is a flat round number like 7, whereas a float has a decimal 7.0. No, I don't have to just bring this over here so y'all can see it. Oh crap, why did you go over there? We were just reading, I was just reading, from like here to here. So I can go over there. I can come back, and we can continue.
When you multiply a number by 0. All zeros. So if we wanted to multiply these two together, let's do zeros times random tensor. There we go, all zeros. So maybe if you're working with this random tensor and you wanted to mask out, say, all of the numbers in this column for some reason, you could create a tensor of zeros in that column, multiply it by your target tensor, and you would 0 all those numbers. That's telling your model, hey, ignore all of the numbers that are in here because I've zeroed them out. And then if you wanted to create a tensor of all ones, create a tensor of all ones, we can go ones equals torch.ones, size equals 3, 4. And then if we have a look, there's another parameter I haven't showed you yet, but this is another important one, is the D type.
I
So
think
the
it's
default
gonna go
data type,
read what I just
so
read.
that's what D type stands for, is torch.float. We've actually been using torch.float the whole time, because that's whenever you create a tensor with Pytorch, we're using a Pytorch method. Unless you explicitly define what the data type is, we'll see that later on, defining what the data type is. It starts off as torch float 32. So these are float numbers. So that is how you create zeros and ones. Zeros is probably, I've seen, more common than ones in use, but just keep these in mind. You might come across them. There are lots of different methods to creating tensors, and truth be told, like, random is probably one of the most common, but you might see zeros and ones out in the field. So now we've covered that. Let's move on into the next video where we're going to create a range. So have a go at creating a tensor full of zeros in whatever size you want, and a tensor full of ones in whatever size you want, and I'll see you in the next video.
Okay, he's going to do that next video. We're going to pick up from... I'm going to probably do a couple off stream. We'll pick back up on stream again. Or something. Maybe we could go back to finally finishing off with this Burtis. Stop. No, no, no. Don't play. Don't play. Don't play. Stop. No.
I want to build a career in
No, stop. Yeah, we're going to have to do this Bert video. It's only half an hour. I'm going to need to finish this GPT video too. Not because I really need to, because I want to. And then just stop, 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 stop. Why do I keep opening things? Chad, I keep opening things.
on the same YouTube channel.
Okay, stop. Okay, so yeah, pretty sure that's... Where did my... Hold up. I just realized chat's gone. So first let's open chat, and then go here, and then go to this, because it's full screen, and then do that. There we go, I fixed that. Okay. Well, I'm tired. It's been a good stream. I need to go upload the stream from yesterday. I still haven't done that. So I could do that. I could upload this stream too. Oh no, I can't, because I turn off my computer. And YouTube does not like it when I turn off a computer while I'm doing that, so I could upload them tomorrow. I'm gonna attempt to upload them tomorrow. Alright. Okay. That's gonna be it for me today. Let's turn up the music, and I will see y'all later.